Machine Learning for Absolute Beginners. Chapter 4. The Machine Learning Toolbox. A practical way to master a new skill is by visualizing a toolbox filled with essential tools and materials. For example, if you were tasked with building a website, your toolbox would include programming languages like HTML, CSS, and JavaScript for the front-end, back-end languages of your choice, and a text editor. You might also add a website builder like WordPress, web hosting, DNS, and domain names. This list gives you a clearer understanding of what you need to become a successful web developer. Now, let's explore the basic toolbox for machine learning. Compartment 1. Data. The first compartment of your machine learning toolbox contains data. Data is the input required to train your model and make predictions. It comes in various forms, including structured and unstructured data. Beginners should start with structured data, which is organized and labeled in tables. Unstructured data, like images, videos, emails, and audio recordings, do not fit into rows and columns. Anatomy of a tabular dataset. A tabular dataset is organized in rows and columns. Each column is a feature, also known as a variable, dimension, or attribute. Each row represents a single observation of a given feature. Columns can also be called vectors, storing your x and y values. In supervised learning, y is already present and used to identify patterns in relation to the independent variables x. Scatter plots, including 2D, 3D, and 4D plots, are tools in this compartment. A 2D scatter plot consists of a vertical axis, y-axis, and a horizontal axis, x-axis, to plot variable combinations as data points. Each data point represents an observation from the dataset, with x values on the x-axis and y values on the y-axis. Compartment 2. Infrastructure. The second compartment holds your machine learning infrastructure, including platforms and tools for data processing. Beginners typically use web applications like Jupyter Notebook and programming languages like Python. Key machine learning libraries include NumPy, Pandas, and scikit-learn, all compatible with Python. These libraries allow for data manipulation and algorithm execution with minimal coding. You'll also need a computer or virtual server to process your data. For data visualization, libraries like Seaborn and Matplotlib or software like Tableau can create charts, graphs, and maps. With your infrastructure ready, you can build your first machine learning model. Standard desktops or laptops suffice for smaller datasets stored as CSV files. Python is the most popular language for machine learning because it is easy to learn, compatible with various libraries, and suitable for related tasks like web scraping and data piping. Other languages like C and C++ are used for advanced machine learning, as they can run directly on a GPU, offering faster processing than Python, which requires conversion before GPU use. Python users should import libraries like NumPy for handling large datasets, scikit-learn for access to popular algorithms, and Pandas for data representation and manipulation. Pandas operates like a virtual spreadsheet, similar to Microsoft Excel, and is ideal for importing and working with CSV files. For those seeking alternatives to Python, options include R, MATLAB, and Octave. R is optimized for mathematical operations and supports machine learning, though it is more commonly used for data mining. MATLAB, a commercial language, is popular in engineering fields, but less so in computer science. Octave is an open-source version of MATLAB. Compartment 3. Algorithms. With your development environment and programming language set, you can import data from a CSV file. Kaggle.com offers hundreds of datasets in CSV format for free. After registering, you can download a dataset of your choice. Beginners often start with simple supervised learning algorithms like linear regression, logistic regression, decision trees, and k-nearest neighbors. They may also explore unsupervised learning through k-means clustering and dimensionality reduction algorithms. Visualization. Communicating data insights effectively requires data visualization. Visualization tools like graphs, scatter plots, heat maps, and box plots help convey findings to a general audience. For less informed audiences, visualization is crucial, while technical details can supplement visuals for knowledgeable audiences. Tools like Tableau or Python libraries like Seaborn are invaluable for creating visual representations. The Advanced Toolbox. As you advance in machine learning, your toolbox will expand. Advanced users handle larger, more complex datasets, often in the realm of big data. This data may be stored across multiple locations and streamed in real time, making it dynamic and challenging to process without advanced technology. Compartment 1. Big Data. Big data describes datasets that are too vast for conventional processing methods. There's no strict definition in terms of size, but petabytes of data currently qualify. Big data includes both structured and unstructured types, like images and videos. Compartment 2. Infrastructure. For advanced data processing, robust infrastructure is necessary. Experts often use distributed computing and cloud platforms like Amazon Web Services or Google Cloud Platform. GPUs, graphics processing units, are crucial for handling big data due to their ability to perform many operations simultaneously, offering faster solutions than CPUs. Originally developed for gaming, GPUs have become affordable and widely used in machine learning. In 2009, Stanford University's Andrew Ng discovered that inexpensive GPU clusters could efficiently run neural networks, significantly reducing processing time. While C and C++ are preferred for direct GPU operations, Python can be used with machine learning libraries like TensorFlow, which can run on a GPU for increased performance. Cloud providers offer pay-as-you-go GPU resources, often with free trials, making them accessible for those without compatible hardware. Compartment 3. Advanced Algorithms. Advanced practitioners use a variety of algorithms, including Markov models, support vector machines, and Q-learning, as well as ensemble modeling, which combines algorithms for unified predictions. Artificial neural networks are prominent in advanced machine learning and supported by libraries like TensorFlow. TensorFlow, known for deep learning and neural networks, supports techniques like automatic calculus for backpropagation. Other popular libraries include Torch, Caffe, and Keras. Keras, a user-friendly Python library, allows for rapid experimentation, though it is less flexible than TensorFlow. Caffe, used for image classification and segmentation, is written in C++ with a Python interface. Torch, based on Lua, is widely used in deep learning at companies like Facebook and Google.